Okay, now we would like to go over some examples of applications of linear equations, applications in solving word problems. But these word problems are not really difficult or complicated or convoluted. As you can see, even the whole problem stating the whole thing is just two sentences. So it's definitely nothing hard per se. Okay, so the very first example says one number is 8 more than 6 times another number. If the sum of the two numbers is 78, find the numbers. Okay, and so to solve these problems, basically is you have to label things. So you're going to introduce a variable and you want to use a variable to label things. So in this example, we're looking for two numbers. We're looking for two numbers that add up to 78, but they tell us something else. One number is 8 more than 6 times the other one. So we can start by saying, okay, well, we can call the first number x, or any letter that you want. You can use n for number. So we're going to say, so let x be the first number. Okay, there's two numbers that we want to find, so let x be the first one. Okay, if x is the first number, then the first sentence tells us something about the other number. It says one number is 8 more than 6 times another one. So that means the other number they're talking about, right, is 8 more than 6 times the other one. So that means we're going to add 8 after we multiply by 6 because it is 8 more than 6 times the other number. So what we do to find the second number, the second number is going to be 8 more than 6 times the other. So you take the other number, you multiply by 6, and you add 8. Or you could read it, you could have written it backwards as well. You could have written 8 plus, because it says 8 more than 6 times the other number. So you could have written 8 plus 6x. That's also fine. Remember, it's the same thing. The order in which you add things doesn't really matter. So if the first number is x, then the other number, which is 8 more than 6 times that number, would be 6x plus 8. Okay, and now the next thing they tell us is that the sum of these two numbers is 78. So they tell us that first number plus the second number, the sum of these two numbers is 78. The sum of these two numbers is 78. Okay, so what does that mean in terms of x? Well, the first number is x, and the second number is 6x plus 8. So that means when we add these two things, we get 78. And that's our equation. And now, to finish this up, we just solved that equation. But that's it. Let's solve this equation. So x and 6x is 7x. So 7x plus 8 is 78. Subtract 8. This is going to be 7x equals 70. And divide by 7. That gives us that x equals 10. Okay, so x equals 10. And now, so we're done. Now we have to actually answer the question. The question is find the numbers. So what are the numbers? So that means the first number, which is x, the first number, which is x, is actually 10. And the second number, which is 6x plus 8. We're plugging in 10 in there for x. This means 6 times 10 plus 8. And then this is 60 plus 8, which is 68. So the two numbers are 10 and 68. And that concludes that problem. So really the strategy is you're going to introduce a variable and start labeling things. Once you label things and you have like everything, all the information in place, then your goal is to try to write one equation that ties everything, and then you solve that equation and get your answer. Okay, so here's another example. Find three consecutive odd numbers whose sum is 177. And maybe I should have been a little bit more specific, but by numbers, right, we're assuming these are integers, whole numbers. Okay, when we say the word odd, that implies that we're talking about whole numbers. So find three consecutive odd whole numbers, or integers, whose sum is 177. All right, so again, first let's start labeling things. We're looking for three numbers. We're looking for three numbers. We're not going to use three letters, three variables. We're only going to use one. So let's use x for the first number. So let x equal to the first odd number. Remember, all three numbers are odd. So let x be the first of these numbers, the first of these three numbers. Now, because odd numbers go in by twos, right? They go by two. So if you have like 5, the next one will be 7, then the next one will be 9. And if the first one is like say 21, then the next one will be 23 and then 25. Because they go by twos, that means the second number is going to be, because they go by twos, is going to be x plus 2. That would be the second odd number. And then what about the third one? Then the third one will be 2 more from this one. 2 more from this one, that will be x plus 2 plus 2. So that means x plus 4. That would be the third number, the third odd number. Okay. Now, if this had been like, if the question had said find three consecutive even integers, then it would really be the same idea, because even integers also are spaced out with a difference of 2 apart. And if you didn't have the word or odd or even, if you just said find three consecutive numbers, then they would be differing only by 1. So the numbers will be x, x plus 1, x plus 2. All right, so just mentioning those because those are like possible variations that you could encounter. All right, okay, so we have labeled everything. Now that we have labeled everything, let's see, can we write our equation? It says the sum of all three numbers is 177. So that means x, so I'm adding all three, so you can add down. I'm going to write it horizontally. So first one plus the second one plus the third one, the sum of all three numbers equals 177. And that's our equation. We're going to solve this and find all three numbers. Okay, add up there's three x's, so 3x, and then 2 plus 4 is 6, 177. Subtract 6, 3x equals, what is that, 171. And lastly, we need to divide by 3. That's kind of a big number, so let's see if we can do it here real quick. 171 171. You could do it by hand. This is not hard. Uh, what's wrong? Okay. 171 divided by 3. That would be 57. Okay, dividing by 3, you get x equals 57. Okay, so that gives us that x equals 57. Now we have to actually answer the question. The answer is the 3 consecutive odd integers or numbers are, well, the very first one is 57, the next one would be 59, and the next one would be 61. Here's another example of an application of linear equations. It says John buys the book for $66.47. And this number includes a 15% discount from the original price. So the question is, what was the original price of the book? So this number is the number that you get after you take 15% off from the original price. So what we're looking for is original price, right? So that's our unknown. So that's a clue right there that that should be our variable. The original price, which is what we're looking for, should be our variable. So we're going to say then let x be the original price. Because we don't know what that is, we're looking for it. That's our unknown. The original price of the book. Okay. Now you need to remember how you find percentages. How to find a percentage? Well, in general, you have to move the dot and then multiply. So, for example, the quick review: if you wanted to find 20% of, let's say, 50, let's say $50. Let's say you want to find 20% of $50. You have to move the dot here twice to the left and then multiply. So this would be 0.20. Move the dot twice, and then you multiply that by 50. So that's how you find 20% of 50. So multiplying that gives you 10. So 20% of $50 will be $10. Okay, so that's what you need to remember for this problem, how to find a percentage. So you move that dot twice to the left and then multiply. So in this particular problem, we need to find 15% of the original price of the book. So that means we need to move the dot twice and then multiply. So 15% of the original price of the book, which is x. 15% of x would be what? You move the dot twice, so that would be 0.15, and then you multiply 0.15 times x. So 15% of x is 0.15x. No, so that would be the discount. This is the actual discount. This is the part that is removed from the price. So what would be our equation then, if you think about it? So if you take the original price and you take away the discount, so the original price minus 15% of x, that should be 66.47. Or in other words, x minus 0.15x should be 66.47. So that is our equation. Okay, make sure that you understand that. There could be like variations of this problem. Let's say you are at a restaurant and you include the tip and the total is blah. So let's say you leave like a 15% tip. and the total is blah. What was the original amount spent on the food? So that would be similar to this, but in that case, because you're going to include the tip, that's in addition, so that would be like plus here. In this case, we're discounting, so we're taking it away, we're subtracting, so it's a minus. But just mentioning that because those are like simple variations of exactly the same type of problem. All right, now let's subtract. This is an invisible one here. 1 minus 0.15 is 0.85x. This is equal to 66.47. And now, to get the x all by itself, we divide both sides by that coefficient. And what do we get? We get that x equals, let's put that in the calculator, 66.47 divided by 0.85. That would be 78.20. 78.2. This is money, so we have to use two decimals. And if you had got a decimal that has more than two decimals, then round up. I mean, round to using the usual rules of rounding to two decimals. Because this is money, you need two decimals. So that's it. So the original price of the book would be $78.20.